Okay, so notes 9.3 is going over arc length for parametric equations. So this first part says recall the formula for arc length. That was L is equal to the integral from A to B of the square root of 1 plus f prime of x squared dx. So in this section right here, they have us go through a proof in order to show us how this arc length can be transformed into parametric form. So there is a proof that goes here. We are not doing it. Okay, so if you're interested in the proof, there's online. Look online for the proof. Okay. What this proof leads us is to the arc length in parametric form, and that is L is equal to the integral of A to B square root of dx dt squared plus dy dt squared dt. So the arc length in parametric form is doing the square root of the derivative of x squared plus the derivative of y squared. So we're just dealing with derivatives again. Okay, and then once we plug those in, we're going to integrate. The bounds here is going to be based off the interval that they give us, and then we'll be able to solve and get a numerical answer. Okay, because it is a finite bounds. Okay. One important thing to note is that this equation only works for smooth curves. So only works. The reason for that is if we had a curve that had sharp edges or corners, can we take the derivative of those corners? No. Okay, we would not be able to take the derivative at those corners, which means we can't use this formula if the graph had sharp corners. So only smooth curves. So number 1 says x of t is equal to cosine t, y of t is equal to sine t on the interval where t is between 0 and 2 pi. So the first thing we have to do is take the derivative of x and then take the derivative of y. So x prime of t is, what's the derivative of cosine? Negative sine. And then y prime of t, what's the derivative of sine? Cosine. Okay, once we have these derivatives, we set up our integral. So this is the integral from 0 to 2 pi. Square root of the derivative of x squared, so negative sine t squared is just going to be positive sine squared t. Okay, negative and a negative make a positive. And then we're going to take the derivative of y and square it, so that's cosine squared t dt. And then we're just solving the integral. Well, notice inside of that square root, sine squared t plus cosine squared t, we know is going to be what? 1. Say based off the properties of trig. So we have the integral from 0 to 2 pi, okay, of the square root of 1 dt. Square root of 1 is just 1. So what would be the integration of 1? T. So we have t, and we're going to solve that from 0 to 2 pi. So I'm going to plug in 2 pi, and then I'm going to subtract and plug in 0. So this is 2 pi minus 0, which is 2 pi, and that is our answer. Okay, any questions on 1? Okay, number 2, we have x is equal to 1 minus 4t and y is equal to 7t on the interval where t is between 0 and 2. So first we find the derivative of x. Okay, and that would be what? Negative 4. Then the derivative of y? 7. So then we do the integral from 0 to 2. Square root x prime squared, so negative 4 squared is 16, plus y prime squared, so 7 squared is 49, dt. Simplify that, and we get the square root of 65 from 0 to 2 dt. So what would be the integration of this? Square root of 65t, because that's just a constant value. And we're going to solve that from 0 to 2. So we have 2 square roots of 65 minus 0, which is 2 square roots of 65.